Okay, let's go over simplifying radical terms. Start with an easy one. The square root of 16 is 4. Okay, 16 is a perfect square. So when we do the square root of it, we get an integer. Let's go over some perfect squares. Okay, they include 1, 4, 9, 16, 25, 36, 49, and so on. These are perfect squares because we could do the square root of any of these and get an integer. So the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6, and the square root of 49 is 7. So this is a perfect square. But what happens when we have the square root of a number that isn't a perfect square, such as the square root of 50? If we put this in a calculator, we'll get some decimal number. But we want to simplify this so that we have a number and a radical. The way we do that is we think of factors of 50. So for example, 5 and 10 are factors of 50. We can actually break this up. So square root of 50 equals radical 5 times radical 10. But we can't do the square root of 5 or the square root of 10, so this doesn't help us at all. Let's think of other factors. Well, 50 could be square root of 25 times the square root of 2. 25 times 2 is 50. And this works because the square root of 25 exists. 25 is a perfect square. So if we do the square root of 25, we just end up with 5. Okay, and then we still have radical 2. So we had radical 25 times radical 2. Radical 25 is 5, so we still have 5 times radical 2. So this is how we would simplify the square root of 50. Let's look at another one. The square root of 72. Let's think of some numbers that go into 72. And we're going to try and think of factors such that one of them is a perfect square. So we should try to see if any of these go in it, preferably the biggest one. And 36 goes into it twice. So this is really square root of 36, square root of 2. The square root of 36 is 6, so this is really 6 square root 2. Look at the square root of 48. The square root of 48 can be written as the square root of 16 times the square root of 3. Square root of 16 is 4, and then we still have the square root of 3. So square root of 48 equals 4 radical 3. Now let me show you something. What if we didn't pick 16 right off the bat? What if we couldn't think of 16 times 3, but we thought of 4 times 12, because 4 is a perfect square, so we could use that. Well, in this case, the square root of 4 is 2, so we have 2 radical 12. So it doesn't look like it's the same answer. But actually, we could continue with this. We could continue simplifying, because we could break up 12. So we still have the 2. The square root of 12 is really the square root of 4 times the square root of 3. So we still have 2 here. The square root of 4 is 2. And still a square root of 3. So now we have 2 times 2, which is 4, radical 3. Same answer. In this case, we figured out the biggest perfect square that goes into 48, and we came to the answer right away. In this case, we didn't think of the biggest perfect square, but we thought of a perfect square that goes into 48. We simplified that, and then we further simplified the radical 12, and we still ended up with the same answer.